The next lecture will be delivered by Nufar Gaspar, who is our data science and solution vertical manager at the IT Advanced Analytics at Intel, and she will tell us about AI inside.
Okay, so good afternoon, everyone. As Chen mentioned, I'm Nufar Gaspar. I work for Advanced Analytics, where I lead a vertical that creates data science solutions for Intel R&D organizations. And I'm going to talk today about the story of Advanced Analytics. And we've been creating solutions for productions with AI and big data technologies for over 10 years now. And over these years, naturally, we've made some mistakes and had some very good success stories, and all of them led us to the way we work today. And what I want to share with you in this session is the key working principles based on which we're working. And then I will demonstrate some of these working principles on my vertical through a more concrete example. So the first part will discuss those principles. And by the way, if you ask about relevancy, I think any company that is facing a rapidly changing market and constrained resources, which I guess are most, could probably benefit from those principles based on which we deploy AI. So these are the 5 principles that I would like to share with you, and I will walk over them one by one. And the first one is that we are using AI to transform work. And I'll elaborate in a minute, but before I do that, I want to give you some motivation or context. So Intel, like most companies in the globe, I guess, is facing an efficiency problem. We're constantly asked by our management to develop, retain, and validate many more products. While those products are becoming increasingly complex over the years, which makes it that much more difficult and makes the manufacturing process a very complex, lengthy, and costly one. And in addition, the market that we're working in is constantly changing, and the customer base is increasing almost on a daily basis, meaning that it's very complex or almost impractical to cover all the existing customers in the market. Now, when we look at each and every one of these very complex tasks, the main bottleneck is the human brains or the human ability to make decisions so that the processes will be accelerated. And what we are trying to do with AI is to enable not just like a linear or steady growth that maybe the efficiency of the regular methods or traditional methods can allow. We're trying to enable an exponential growth. And this is where we think AI is a game changer and the key technology that can break this very steady decrease or break the efficiency problem and help us get to where the company would like to be. So a few words about what it means to transform work with AI. What we're very much focused on is not trivial decisions, one that could have been automated by robots even centuries ago. We're targeting judgment-based cases where humans are making intricate decisions, and we're trying to automate these cases. These are decisions that are made by the knowledge workers, by, in many cases, the smartest and brightest brains that a company has. But AI, in many cases, can make similar or more complex decisions because it can learn from a much wider data set with a much higher dimension, and can do that in a fraction of a second, where if we could, maybe we would have put an expert in each and every decision point to make such a decision, but we know that that's not practical to put a human brain whenever a decision has to be made. So the scale that AI unleashes is almost unlimited. And finally, to make sure that we are working on the right things, we always have to measure the quality of the actual decision-making and the actions that people would have made, but now AI is doing, in order to make sure that we are solving the objective function, the business process that we're trying to optimize, rather than just the algorithm performance and other things that can be measured but are not the ones that are critical for the company. So the way we are currently built is in a vertical method, and for those of you who attended Moti's session, he kind of briefly touched in it, but I do want to emphasize on where we're currently selecting to work, and these are the places where we currently believe that Intel can get the highest value. So those are the 6 current AI startups that we're currently working on. And the way we build the workforce is that each vertical is highly focused on a specific business domain, focusing on a very specific set of business goals. And each such vertical has a very large both autonomy and accountability to make a difference within this business domain. So the first vertical is all about embedding AI into Intel products. How can we make the products smarter, more adaptive, and respond to the different users of the systems or the different usage mode of the same user to the system? Because naturally we know that not every time that I open my PC, I need the exact same behavior if I play a game or if I browse the web. And by learning the actual usage modes, we can get a much more personalized and much improved power and performance experience for the user simply by being much more adaptive and smart in the way that the system makes the decision. The second vertical is the one I lead, and this is highly focused on hardware validation. I will elaborate on my vertical a little bit more in the second part of the presentation, but for now, I will say that we're very much focused on how can we improve both the quality of the product and the speed at which the product is being validated. This is an area where there is a lot of data and many human decisions that has to be made in order to find all quality issues. And we are getting to a point where the system can automatically identify hidden bugs that humans have missed. And this is where ultimately we think the highest value lies. The third vertical is focusing on the manufacturing domain, where if you can anticipate in advance that things are about to happen and make actual actions according to whatever you uncover that is about to happen, whether it's a catastrophe or things that can change the system, you can significantly reduce the manufacturing cost, increase the yield, and overall improve the manufacturing process. The fourth one is around the testing processes, where in the production line, each and every unit is being tested many times and a lot of data is being collected. And this vertical is very much focused on how can we personalize the process of testing each and every unit, such that if I have a very good unit, I can give it like a speed up or a free path, whereas if I have a faulty unit or one that we should investigate much more closely, we can handle it very differently. The outcome of such personalized testing is our ability to, first of all, increase the output of the factories, improve the quality, and reduce the overall cost, because we're making just a very precise decision as to what should be tested and how much. In the sales domain, and this is where Moti touched a little bit more, there is no practical way to assume that each and every potential customer of Intel can be engaged by a salesperson. This is impractical to assume that. So where we see the highest value of AI there is by automating a completely autonomous end-to-end sales process, from uncovering opportunities through crawling the web and any other method that enables us to arrive to an opportunity, to offering the right products to the right customers at the right time, and finally conducting the end sale without any salesperson in the loop. And the last one is the relatively newest vertical, and that would be a collaboration with Mobileye, where the Mobileye system is deployed across many fleets across the world that collects real-time data from cars. This data is highly valuable when you want to map out insights coming from the roads in real time. For example, whether I have a hazard on my road, whether there is open parking, or anything that a smart city, for example, would like to use to make a much smarter and informed decisions from real-time data. And over the years, I guess each vertical kind of specialized in a different kind of algorithms or kind of technology. But what's interesting to note is that the underlying principles and the one that I'm sharing are very much similar across all of these 6 verticals. And we get like an enforcement each and every time that these principles actually work if you want to transform the way work is being done with AI. Okay, so in many times when someone sees this foil, a question arises of how do you decide where to work, whether it's which verticals to focus on, or whether it's what specific projects do I want to work within this vertical. And we're trying to be very strict in our ability to continuously question whether or not we are working on the right stuff. Again, and whether it's a vertical level or a specific project. And we're always looking into new opportunities because we're very much value-driven and looking to work on the places where we think the highest value can be achieved with AI. So these are the main criteria that we are currently using to select what to work on. First of all, it has to be the critical stuff, the core businesses of the company, the ones moving the needle, that without them, the company would probably have poorer performance, or with an improvement in them, the overall output and results of the company would improve. So in our case, it's naturally the product development, the manufacturing, the sales. These are the areas that are most vital for Intel's success. Then it has to be unique. There are many very big problems that are common across multiple companies. I don't want to go and solve something that is exactly identical in every company in the world. Probably I prefer to take a vendor or someone else to solve a very common problem. I prefer to focus as an in-house AI shop for Intel on something that is very unique to Intel, whether it's because the data is unique, the scale is unique, or simply it's something that most companies are not dealing with such a problem. Then, as we mentioned, one of the key goals would be to reduce the human bottleneck. So I am looking for places where I don't have enough people, or I don't have enough experts to make the smartest decisions, and I think that I can replace them with AI to kind of shift or altogether eliminate this bottleneck. And it has to be a place where it either impacts the upper line of the company or the bottom line of the company that has a significant and critical dollar impact for the company. Examples would be the time to market, the actual product cost, and other key dollar drivers for a company like Intel. So with that 4 criteria in mind, there is also a 5th one that is maybe as important as the 4th one, and that would be feasibility. So over the years, we kind of established the key feasibility criteria for when we should go after a problem, even if it's very high value. If the feasibility is not in place, probably we should skip and go work on something else. So the business process has to be one that creates the data and will be able to accommodate AI, but it also have to have like a line of sight for collecting the data even if it's not there yet. And the systems should be ones that anticipate a performance that we can meet. If, for example, I have to make a very complex decision in a matter of less than nanosecond, this is probably not a practical place for me to go and work there. So we're evaluating both the business, the data, and the system criteria, and just when we see there is a line of sight for feasibility or that the problem is feasible enough today, then we will go after such a problem, meeting the other 4 criteria. The way the teams that are working on such a problem is built is in a very like interdisciplinary teams that has a lot of autonomy and a lot of ability to move simultaneously. So myself as a vertical manager, I have a lot of freedom and a full autonomy in the way my team is built, so that I can go and create end-to-end solutions in production in a timely manner. And the way we do that is that the teams are compiled both from data scientists. Those are the people that their job is to take the algorithm from ideation to production in the highest quality possible. I have the AI platform manager, platform engineers, and Moti explained a lot about the proficiency and what it takes to shift data around and make it in a very effective way that enables to deploy AI in production at scale. Then we usually would work very closely with a subject matter expert, meaning someone that both understands the data in depth and the business process in depth, and the way these two correlate. They can be people working from within the team or partner with other people from the business units. And all of them together are being orchestrated by an AI product manager. And this is not a product manager that just know how to do software. These are people who are proficient in data-based software, meaning that they understand how to speak both data and software and business and kind of glue everything together. And they are probably one of the key success factors for such a team to move faster, because they make everything kind of play together in a harmony. And finally, the CEO or the vertical manager is very similar to any CEO of a startup. The role of someone like that would be to make sure that we have the right portfolio that is able to scale, that brings enough value, and close like internal deals with various teams inside the company. If we need more investment, we have to go and pitch it to make sure that we are getting more value out of it. And in many cases, each vertical sees itself as completely accountable to make the right decision, bring enough value to make it survive. So there is a lot of hunger in each such team to succeed and prove that it's valuable enough for the company. Now let's talk a little bit about the actual AI. What are the key components? And I mentioned that these 6 verticals kind of specialized each in a different direction, but when you look at it in a more abstract way, each vertical has key components that is very much in common with the other verticals, because these are the underlying concept that is unified to all of them, and these are probably the key enablers for bringing AI to transform work, to replace knowledge worker, decision-making processes, to bring this high value. So the first component, I want to define it like an agent. It's a specific AI application that is very good at a very specific task in making a decision or a specific business application in a very good way. And it's equipped in everything that it needs to take the actions to derive to the desired business goal. Each such agent would usually deploy, or would always deploy, a lot of judgment, because as we mentioned, it's all about replacing judgment-based decisions. If it's something that I can automate, it's very simple. I don't need AI. AI is too expensive to go after. If it's something that I can just enumerate all the options and automate it, it's not worth to go and do all this work if I could simply just have a simple if-else mechanism instead of such a more complex system. So it has to be places where experts, knowledge workers, are making decisions, and these decisions are not trivial, and this is where we see the highest value. Then they have to deploy algorithms that when you feed them more data, they improve, whether it's more history, whether it's more information. Otherwise, if I can use a stale or static data, I don't need AI. Again, I can automate it and I can go home early. But when I find a case where more data means more quality and better decision making, this is where I know the highest value lies. And finally, we have to have an AI platform that can orchestrate all of these components in a timely manner that enables to scale easily, because otherwise it's not going to be, it's not going to have enough ROI, because I will have to go and redo the work each and every time. So a platform is something that enables me to move faster. Now, in the B part, I want to demonstrate the key principles through my vertical. And just a few words about context or introduction to hardware validation. So Intel products and most products these days are very complex. And the role of validation is essentially to find all bugs before the product is released to the market. Now that sounds fairly easy, but with products being that complex, it's almost impractical to assume that a human would identify in advance every usage mode of a system and anticipate any potential bug. This is why it takes a lot of time. But the implications of missing bugs, at the worst case, are massive recalls that cause millions of dollars and reputation damage to the company. This is the most dramatic maybe outcome, but even less dramatic outcomes, which are very bad for a company, would be to find a bug late such that you will have to go and create a new prototype. These days, creating a new prototype for a product will mean that you will probably delay the launch of a product in about 6 months. So even the bad aspects, or not the worst case, are quite bad, and thereby validation engineers are very much focused on how can we uncover bugs, how can we find everything as early as possible, and as I mentioned in the beginning, not with an unlimited human force, meaning that we have to kind of change the game of how we go about doing the validation. And what we are trying to do, or the large opportunity for AI is how can we automate the critical validation decision-making, the decision processes, such that we will increase the quality and hopefully find in advance some of those very hard or tricky to uncover bugs. This is the way the overall flow of the systems of my vertical are working. And I will, after that, demonstrate it through a very concrete example. So in all of our solutions, the input would be millions of tests for validation. And from each of these tests, we're getting the log files. What were the test configurations? What were the test outcomes? Whether it covered specific functionalities or not, whether it failed, and if it failed, what happened in the way to the failure. A lot of information that can help us make many decisions regarding the validation processes. Then we ingest the data to our big data platform. Our platform is on-premise at Intel based on Hadoop and Spark ecosystem. In this platform, we deploy various agents. Each of them has a specific task, but in general, in most cases, what we end up having is both a machine learning algorithm and an optimization algorithm, because in the first part, we kind of have to identify patterns, correctly, for example, classify things and whatever, but then we always work with constrained budget, with limited number of tests, with limited number of hours or any other constraint, meaning that it's not enough just to have the right learning or the right pattern identified. We then have to go and optimize it on a larger scale. And the result or the judgment that such a system would have is various services or various outcomes. They can be creating new tests to be much more efficient in validating a specific functionality. They can be to optimize the overall testing that are being run, or they can aid the human expert in the debug process. So these are just some concrete examples of what can be done with AI in validation. And to be a little bit more specific, let me tell you a few words about ITEM. ITEM stands for Intelligent Test Execution Management. And the problem that ITEM is trying to solve is relatively familiar, both in software and in hardware. Most validation teams have like a golden suit of tests where they try to cover as much as possible of the products. And what happens usually with those test lists is that they become very long. They have many, many legacy tests that they don't have, most teams don't have enough time to update those lists frequently enough such that those lists will remain relevant and with high quality over time. And when we select such a golden list, it's always a matter of balancing between how long or how costly it is to run those tests versus the amount of bugs or the quality they end up having. And in many teams, these lists are kind of a root cause for many quality issues because they either don't catch the bugs early enough or don't catch them at all. So the opportunity here is naturally to automate and make those selections of tests much more dynamic. And the data that we're utilizing is both the test configurations, what were the actual tests that were running, and the test outcomes, whether they arrived to desired goals or not. Over here, the agent is a combination of pattern recognition algorithms, and the goal of these pattern recognition algorithms is to tune the test, tweak with the configurations to ensure that those tests are validating very well whatever they were aiming for, and an optimization algorithm that tries to holistically maximize the amount of functionalities that we cover with a given budget. So it's like a two-step process where we first do the pattern recognition, create a large set of patterns, and then optimize which of those patterns would actually be used for different usages to maximize the value in light of a budget. And the AI platform that ITEM is utilizing enables us to create a very large scale, meaning that first of all, we retrain the algorithm at least once a week, in some cases even more frequently, and we have deployed and are deploying items across dozens of teams at Intel without having to change the software or the overall architecture. The outcome of ITEM is if I talk in my terms, is a better judgment. We get to automate which tests are being selected. We get to do it very frequently, when without AI you couldn't have done it frequently enough. You couldn't have done it on a weekly or daily basis, like in many cases you probably should. And we have proven that we can significantly, you can see the numbers, significantly reduce the amount of tests being run. It's almost by 3/4 less tests that are being run, but still uncover many more issues. So it kind of proves that you can, with AI, break the trade-off between cost and quality. And this is what we do with ITEM. Now that would be my last content slide. I just wanted to end like in a more personal note. So it sounds all the time that what we're trying to do is eliminate humans and replace them all with machines that are going to be smarter and better and faster. And this is really not the case. The case, and maybe my opinion, but what we're trying to do is actually to have the AI and humans work better together. Because if you want to replace some of the judgment and some of the knowledge workers with AI, that means that you're going to free people to work on what people are better at. That means innovation. That would be to start something from scratch, where this is something that AI can't do, because when you start from scratch, there is not enough data. So the overall notion of what we're trying to do is to have human and AI work better together, because we believe this is the ultimate outcome, where experts and AI collaborate to get to a better results and ultimately reach like much more improved work, both experience and outcome. So with that, I want to thank you. So it depends whether, the question was how long it takes to start from ideation to production. The question would be whether it's like a spin-off or something that is, in some cases, similar to something that we've worked before, and that would be even a matter of weeks. When we start something from scratch, when we have no information, it's usually a matter of months. That's the cadence, more or less. בתאווה.